Hi all, it's great to have you at our second chapter of Polkadot India's Substrate Saturday Bootcamp. That's a highly competitive Rust and Substrate training series within the country. A big welcome to you all, especially as this batch or cohort that's going to be doing this and also going to be getting placed into some of the biggest global projects in the Polkadot ecosystem. So congratulations on picking this up, and this is a promising technology and you're picking it up at a very early stage, and we are all totally with you in this journey. Now, please note that we have an exclusive Discord channel for the developers. So do fill in a form that's in the chat box and stay connected. And for those of you who are already in it, keep it interactive, ask questions, share your knowledge and your views, participate in every task and assignments that come your way, and don't shy away because we are all learning together, right? Now, let's start off this session. So Substrate, guys, is built on the Rust programming language, which makes use of the novel design patterns to enable development of code that is safe and fast. Now, although you don't need to know Rust to get started with Substrate, a good understanding of Rust will allow you to become a better Substrate developer. But what does it take to be a developer in the world of blockchain, Web2, Web3, the metaverse, and the likes? Now, it's these skills of Rust and Substrate, and that's what we are here for, to give the skilled and desired Indian developer base and the global developer base at this case an edge over many with this focused training. Now, before I pass it on to your trainers this evening, let me give you an overview again of what's in store for you. So let me again take you through what we have already covered in our website, if most of you must have already checked. Now, as you know, we at Polkadot India are having this bootcamp exclusively for developers. Now, this is going to be a 3-month program, and it's going to have 6 interactive sessions, which is going to be only for developers, like we said. And this is going to happen every alternate Saturday, which is going to be your curriculum training program with our set mentors. Now, what's going to be happening in the other alternating Saturdays is nice little workshops and great interactions with actual global tech leaders from actual real life projects. So that's going to be happening. And so we hope that all of you take really keen interest on this. And it's very important that all of you take active participation in this and you take part in it every single time, because that's what's going to matter by the end of it. People who want to get placed need to be a part of the entire thing, including the workshops. So, and what's also important is the assignment and tasks that come your way, because you're all going to be certified by the end of it. And without completion of the actual tasks and assignments, it will be difficult for us to gauge your growth and for us to put you onto those real-time projects, right? And always feel free to reach out to your mentors and trainers on the Discord channel. And you can always run your doubts and queries by them at any point, right? And you're going to have a lot of live coding experience. And even if you have any problem statements that you want to specifically cover via code, you can always reach out to our mentors on that too, right? And also, if you want like a real brief of the curriculum, you can always go through our website. But like we said, we are covering everything on Rust and Substrate from scratch, and we are doing a lot of live hands-on training and live coding that's going to be going on. So make sure you're involved in this program. Right. So I think it's time I pass it on to the trainers. But before that, it gives me great joy to announce that the Polkadot India community exclusively has our own custom link to the Polkadot Pathways program. Right. And now Polkadot Pathways is an invitation only community where you can learn a lot more about Polkadot, Kusama, and Substrate. You can also get recognized for your efforts with points and your reputation. And you can also connect with other members in the Polkadot ecosystem, right? So in your chat box, you should have your personal link to Polkadot Pathways for being a member of this community and for being a part of this particular Substrate program. So don't stop reading and learning with this comprehensive portal. And all the very best to all of you who have taken the superb step, and give it all your attention, like I said. And soon you'll all possibly be working with all these top projects that we are talking about. And we have some great recruitment partners on board, including A-Star, Polkadot, Polka Fantasy, and a lot more, So I'll now hand it over to your mentors and curriculum designers. So we have Lokesh, Varun, Tejas. They are the brains behind some of the most interesting upcoming Indian crypto projects. Guys, it's amazing what the team is out here to do and what they've put together for you. So over to you, Lokesh and Tejas. They're all yours. And yeah, hope it's a good one.
Thank you so much, Ananya. So first of all, hey all, and thank you for attending this session. So I want to make some things a bit clear. So this is going to be a casual interaction between us and all the participants. So if any doubts occur in your head, just blurt it out. I know the more we ask, the more we get clarity on something. So don't shy away, like Ananya said. So yeah, let's start. Hello, Vish.
Sure. Good evening, everybody. So yeah, I'll just jump right into the topic. So first and foremost, I just want a little bit of news. So I just want to know how many of you here are aware of Rust, or you have Rust installed on your system and are willing to code alongside the session. You could just leave your comments in the chat. So if everybody can
sorry to
screen right now.
Yeah, Lokesh, sorry to interrupt. Few people are saying that they don't have it. So can you share the links? Meanwhile, they can install it.
Yes, sure. So I will be giving all of them, all the links, and when it's necessary, you can install it. So to begin with, I'll just give them an introduction, and then you could start. Right.
Also, Lokesh, one more thing. So if you don't have Rust installed on your system, you can also go on the Rust playground if you want. So yeah, so as you can see, Lokesh has opened Rust playground on his browser. So just type in Google Rust playground, and yeah, you can access that.
Yeah. So meanwhile, I also want to add on that most of the code we're doing should be fine with Rust playground. Only when I get to the part where they're building a big project, probably we'll start doing it on our system. So whoever is using it, yes, Neil, you don't necessarily need to install Rust for most of the session. Only where we get to the part where we're building a new project using the cargo commands, that is the only part, but that also you can do it on your own later on also. And if you want to install Rust as well, so I'll just leave a link here. So yeah. So you can use this to install Rust. This mostly works easily with Linux or Mac OS or any Unix thing. However, those who are working on Windows and stuff, so you could always click on the learn more, and Windows is pretty simple. All you need to do is install this Rust init.exe. Right, this should be about 5 minutes of install process, not more than that, and you should pretty much be good. But yeah, for the first part of it, most of you can just use Rust playground. You don't need to install it on your system. So yeah, that also works. So to begin with, we have these sessions in a format where so basically we for the first 2 sessions we are going to give you basically an intermediate brief of Rust and a little bit advanced concepts of Rust, so that you can carry this on to learn Substrate framework, because this is a requirement if you need to jump into Substrate, right? And that is what I'll be covering today mostly. And regarding, like, especially with the topics, what I'll be doing is mostly going to do with the primitives of Rust. What is Rust basically? Why Rust? Like, why people have to use Rust, and then concepts of control flow statements, then concepts of common programming concepts with variables, constants, then the loops, and a little bit about how object-oriented programming is so there is no oops concept in Rust, but how does Rust employ features that would be needed from oops, right? It's not exactly oops, but Rust has another concept of traits which is used, and structs. So these are the things I will be mostly covering today. And as all of you know, you can always find out the session details here. And we have about 6 sessions planned as informed. And each of the session, at the end of the session, we will be giving you some take home work assignments that you will need to complete and submit. And to begin with, I want to make sure that everybody has created a GitHub account. And please clone all the projects or links that I ask you to download, so that you can code it and commit it for every function that you write. And this this code can be submitted as your assignment completion to the Polkadot India team, where it will be reviewed for your certificate of completion. Right. And what's the bright side about all of these things? So you do get to talk to industry experts who are currently working on major projects on the blockchain front as well as Rust front. So from them, and we have our in-house team who will dedicatedly sit with you, work with you. And whenever you have any doubts, you could always reach out to us in our session. And please stop me if I'm going too fast or if I'm going too slow. Please let me know, so that we can always like work it out during the session, right? And the most the fortune of this entire 3-month program is for you guys to be able, find a job through our recruitment partners, any of these companies here, and also our projects. So yeah, I hope everybody's ready. Let's just start.
One more thing I would like to add, Lucas, before we begin.
Sure.
So Rust really helped me in understanding how how code works in general. So all the concepts got very, very clear, and I was able to like jump from one language to another only because I had the basics very clear. So which Python didn't give me when I was coding in Python. So the best reason for learning Rust is to write good code so that you can be a better programmer, and also you can know the intricacies of these languages that you are going to pick up. So Rust will really, really help you in achieving all of that. So yeah, let's begin.
Sure. Thanks, Ayush. So yeah, that's the most bright thing for me. What keeps me coding every day is that I'm happy that I'm coding in Rust. At my project that I'm doing. So yeah, that's mostly my satisfaction.
Same here.
Exactly. Yeah, that's the main thing. It's fun. It's so to be honest, it's a tug of war between you and Rust on a daily basis with the compiler. But it's like it's a war you want to fight. It's something that you want to enjoy. So
True.
You'll end up breaking your head, but at the same time, the satisfaction at the end of the day when everything works, I think it's
worth it.
Yeah, it's worth it. Yeah. So
right.
Cool. So to begin with, I just want to give you a little bit of intro to what Rust is. So Rust was actually an open source project that started off in July 7th, 2010. And since then, the concept of Rust was to be an alternate to C++, which is systems programming, right? And the main selling point of Rust, or like the main advantages, is simply it's fast, it's secure, and it's basically like you have concepts of fearless concurrency, and it's just ease of large projects being able to handle large projects and how fast the system can work, right? So how is Rust doing all these things? Like to give you a comparison of how fast Rust is. So if you were able to do an ETL project on Python, right? So ETL is extract, transform, and logic basically. So what happens, like say if you were to read from an Excel file and you want to compile some data back into some format that you have written, say you have about 10,000 lines of code in Python, this would approximately take you about 5 minutes or so if this was on Python. But Rust would do it for you in like a matter of probably within a minute. So this is a brief comparison of how fast Rust can be. And why is Rust so fast? It's because of the architecture that is underneath the basically the compilation layer that Rust uses, right? I will tell you more about that as I code, because I don't want it to be like I just give you the theory, then it's not going to do it. So yeah, I do have certain questions. So is Rust good for data science? Rust can definitely be used for data science. Yes, the option is yes. But however, data science is a field where people are not really going to be bothered about how good my code is. You just want code that is running effectively, and you don't want to break a head writing code, right? So which is why scripting languages like Python and shell scripts or that are used, right? So, but there are AI programs written even in C++, Rust, and low-level languages that you want. So, how is Rust more secured? So, yeah, definitely, I will get to that point. So, before I want to show it to all of you via the code as well. So, just a little bit of what basically Rust you need to know is Rust is a strongly typed language, which means you will need to mention every single type before while you're instantiating it or declaring it, right? And this is a compiled language. It's not a runtime language like Python is a runtime language, and JavaScript is a runtime language. What's the difference between compile time and runtime? So basically, a program like, for example, Java or even C++ and Rust have to be compiled for the program to be started. You execute it as a binary file, whereas Python or JavaScript, you can run it on your terminal or any runtime environment that is being provided to you, right? So JavaScript has npm, Python, you can just start off Python and start coding, right? So that is not how Rust works. And then Rust brings it's an idiomatic language. You mostly work with idiomatic style, and it also brings in concepts of functional programming, which is encouraged, right? And the main reason, one of the reasons why Rust is very fast, is because it doesn't have a garbage collection. So for people who do not know what a garbage collector means, so as simple, have you ever, like in Python, people do not have to use you don't have, while you're writing code, you don't have to worry about a variable that is allocated to memory and deallocated. You're not doing that as a programmer in Python or JavaScript. However, in programs like, languages like Rust or C++, you have to proactively in your program make sure that you're allocating memory to it, and once your function whatever is completed, you need to deallocate that variable from your memory. So what is the purpose of garbage collector here? This does it automatically for you. The garbage collector is another layer that languages like Python use, so that the garbage collector can handle all the memory management for you. That is the pros of what I would say about a garbage collector, because you don't have to sit and worry about writing complex code, handling memory details and stuff. But but the downside to it is the garbage collector itself, the layer is heavy, and even your simple projects become very big, and it's not a reliable layer. Anything can break if there are small bugs in your code, and this can only be known at runtime. At compile time, you don't know the errors or so you could have say that you have completed your program, but it not necessarily is safe. So yeah, these are all the cons of what it is. I will talk more about the garbage collector and the model that Rust deploys in probably the next half an hour, but yeah.
I want to interrupt, Lokesh.
Sure.
So regarding compiled and interpreted, so the difference is actually there is not a difference, but there is no difference between interpreted and compiled. It's the difference with how it's executed. So interpretation is also compilation, but compilation at runtime. So for Rust, you have to compile everything first to execute the program. But in Python, you don't have to compile it. You run it directly. So that's the difference between interpretation and compilation. Both are compilation, but they are executed differently. And the other thing, can you go one slide up, Patish?
Yeah, sure.
All right. So strong and static typing, it's like defining types for your variables or your parameters. So this is one type of security that Rust provides. referring to that question previously. So this is like one of the types of securities that Rust has. So yeah, it's quite secure in other layers as well. So yeah, and no garbage collector. So that's a win-win situation for all of us. So yes.
Yes. So yeah, thanks, Ace. So that's mostly about just a brief of what Rust is. Then again, so I will take this in detail because we have a concept of ownership which Rust deploys, and that is where I'm going to explain all of this in detail. I just want to give you a little bit of overview of before even reaching to that point. So this is a quick comparison on Rust and other languages, Python, C++, and Go. So C++ is of the same. So Rust is just a replacement to C++. But now, why would I use Rust over C++? Because C++ has certain security bugs. So mostly to do say is the seg fault errors. What are seg fault errors? Seg fault is basically when your variables or stack frames in your code run out of memory. Like there is corruption in memory, right? So these are seg fault errors, and there are no data races in Rust. So what is a data race? Please make sure, I want each and everybody to make a note of data races and ask me when I'm teaching ownership, because there I'm going to cover data races in detail. But before that, I want to make sure that you guys are following what I'm saying, right? So I will cover data races in the next couple of hours. And so yeah, mostly these are the kind of things. So now Go and Rust. So Go again has so the difference between Go and Rust is basically that Rust is really fast. Go is also really fast. Go is a brilliant language. Go tries to solve the same problem that Rust is doing. But the thing is, what Go is trying to do is Go is a language that is trying to cater to all different domains. It's one big pot of your entire soup, right? But however, Rust is only trying to give you three main features. It's fast, it's secure, and it's reliable, right? It's a robust language. That is the only thing Rust is trying to do. So which is why I prefer Rust for big projects and backend projects, and even small, like lower level languages, like projects like writing the LLVM layers and all that. So yeah. And moving on, so the Rust features, I'm going to cover all of these things. So yeah, but here it is for you for just a glance. Yeah, but we'll get into it via code. And I just want to give you a little bit of overview of what's happening in Rust. Why Rust? Probably most of you guys have a question on, like, see, Python is the most, language that have been, encouraged for people to start off with. Now, Rust, you've been saying Rust, but why Rust? Is there any use case for Rust? So lately, there is a Rust boom that's happening. So there's a high demand for Rust developers, but lower supply of skilled Rust developers, simply because of the learning curve. The learning curve in Rust is a little bit complex. However, it's not that complex that nobody can do it. It just, you just need to put 1 month of effort and you're ready for it, right? And some of the projects that I want to proudly say is that most of you know Amazon Video Prime, right? Prime Video, sorry. It's a streaming service where you can watch shows, movies, and stuff, right? So Amazon has rewritten almost 37,000 lines of code from C++ to Rust for their backend service, right? So that is one production ready application that is using Rust. And second, there are companies like Discord changed. So Discord initially deployed one of their features on Go, but then decided to remove it from Go and put it up on Rust. So one of your Discord features is running on Rust production code, and major developments are happening on the cloud platform. So AWS and Microsoft, Azure, you must have heard of all these cloud services. A lot of modules that are written in C++ are being rewritten in Rust and being deployed. Even now, as we speak, most of you should know Amazon SageMaker. Does anybody know what Amazon Sage is? Like, if you've used it, but so it's a service that AWS provides. So they have rewritten some of their code base to Rust. And so even if you just Google Rust SDKs, you will start finding AWS Rust SDKs, Azure Rust SDKs that are readily out for your production level code. Yes, SageMaker is for ML, correct. So a lot of these things, and even Amazon Lighthouse. So if you've heard of Lighthouse, even Lighthouse has been, a certain amount of code has been rewritten on Rust. So there is a lot of projects at production level already running on Rust backends, right? Simply because it's more secure, it's more fast, it's simpler to handle a large code base in Rust. So these are the things. The adoption for Rust is happening as we speak. This is why everybody needs to learn Rust, and simply it's like they just pointed out. So as a programmer, I would say anybody can code. Anybody can just pick up a language and code. But what it means to be a programmer after, once you are like 8 months down the line, you need to understand how software works, the software engineering concept. How do apps work? How are apps connected? How can you play a game so fast on online servers? The response is insane when you have 10 people or many who are actively playing on the current server, all these things. So it's the concept of software engineering that you'll start pondering into, basically, and Rust will help you understand these concepts. So, and it's not just Rust, any language that you take. I think for me and Tejas, it was Rust that helped us to do that. So a lot of languages help you do that, but for us it was Rust. So yeah. So yeah, this is about it. I just want to start getting into the coding part. Before we start getting into the coding part, I just want to know if anybody have any questions so far, or anything you want to ask.
You can raise your hands. We can unmute you guys if required. Yeah, Vishal, you can ask a question.
Hi, Lucas. I just wanted to know that because we are doing this in context of the Polkadot, any particular preference why Polkadot has chosen Rust as the programming language for them?
So the main reason why Polkadot has chosen Rust, or a lot of blockchains, not just Polkadot. There is Near, there is Polkadot, there is Solana. Then there are many, even Dfinity. Dfinity also has their entire code base written in Rust, though they have another programming language, but that programming language's compiler is also written on Rust. Why? It's simply because it's fast. It's the model on which Rust is built on. It's the ownership and borrow model. So this ownership and borrow model makes programming for users basically a bit easier when compared to C++, because there's a concept of allocating memory and deallocating memory. Vishal, have you worked on C++? Do you know this concept?
Yes, I do.
Yes. So as a C++ programmer, you must have a hard time always referencing, allocating memory to a variable and making sure at the end of that function you have to deallocate it, right?
Yep.
Yeah. So that is overcome in Rust by the ownership model. It doesn't mean that Rust doesn't have memory safety. Rust is memory safe. So what happens in Rust is they have a concept of traits where you have a reference and dereference. So what happens is and the drop trait. So automatically when you assign a variable in Rust or instantiate it, there is a reference to that pointer which has been given, set at stack. For now, let's keep it at stack, right? And the moment your function is completed, that is your close brackets are ending, automatically the drop trait is implemented for primitive types. For example, integer or unsigned integer or a string type. So the drop trait is implemented. So what does the drop do? It just basically deallocates. You as a programmer are not going to manually go and deallocate the memory for each and every variable that you did. So this is one such example of how code is simpler. And since there's no garbage collector, C++ has a huge garbage collector layer, right? It makes the code really heavy, but there's no garbage collector because thanks to ownership and borrow model, it's just so small. Programs can be like small enough, but very fast. These are the main selling points. So if you ask me, are there downsides to this? Yes, there are downsides to this. Major downside, like I said, is writing code. You must know how hard it is to write C++ code.
Yes.
So I wouldn't say it is as hard as C++, but yeah, it is hard. Writing Rust code is hard, but it's any day better in terms of security, because you're not giving the developer the choice or the freedom to commit errors.
Got it. Thank you.
Right? Yeah.
So, Lokesh, we can take one more question. Ryan, you want to go ahead?
Yeah, so I wanted to ask that there's another language called Viper. So,
Okay.
so like in comparison with Viper, why should one use this Rust? So what is the
Uh,
comparison between both? So because
so
Viper is like quite related to Python, so it would be like simpler to write in Viper.
may I know your name, please? I'm sorry, I do not. I
Yeah,
don't
I'm
have a
Ryan.
screen.
Ryan.
Ryan. So Ryan, is Viper the language you're talking to write Ethereum smart contracts?
Yeah.
Okay. So I haven't written. I mean, I don't know much about Viper. So I can't say much about it. But if you're saying it's more like Python, Python and Rust are two different languages.
Yeah.
Python is a scripting language and Rust is a systems language. So and Viper for Ethereum contracts, I believe, is just to write simple code, because Solidity also is a simple code. But Rust, on the other hand, is for you to for the entire architecture of the system to be like robust and strong. That is what Rust gives you. It's basically a systems program. So comparing a scripting language with Rust is not one would do. However, we always can say what are the bright sides and when to use. For example, if I want to build a web app, right, I don't need to give people, like, I don't need to break my head on how I'm writing code, where I'm managing memory, like, and all that. I can sacrifice doing all that to have a bigger code base, a bigger, like more memory, and have a garbage collector that takes a lot of the runtime time, and a little bit slower in use, and all that, while I don't have to sit and worry about memory safe and complex code. This is in terms of a web app. So I believe even in a smart contract, like, you could do that. But when it comes to system programs, like very core like parallel programming, concurrent programming applications, I believe Rust is where it shines. You need such programs. You can't do that with Python.
Okay.
Does that answer your question?
Yeah. Thank you so much.
Cool. So yeah, if that's all, I'll just start off with the basic. The first and foremost is our hello world.
Lokesh, I think everybody has this question. Why do you think Rust is preferable over Solidity? If you could clarify, it would be the last question.
Okay, why Rust over Solidity? So to be honest, at the end of the day, it's a choice of preference. So it depends on what project are you building and what is the scope of your project. So if you want to just build a very simple project using like simple technology, which you just don't waste time building the project, right? Because building a code base on Rust takes time. So one thing that I would say is the time thing concept. So building it on Solidity is a fairly easy language. It's very beginner friendly, and even it's on Ethereum base, right? So it's two different things. It's choice of favor. But one thing as a developer, I would say, if I'm making the choice for my application, is time. Building it on Rust, say it would take a month longer than you would build it on Solidity. So if you can't afford that time, and that's what it is, then yeah, you would choose other languages. But then again, now you're going to cater an application to say a huge crowd, and this application has a lot of backends which needs to compute, like on a microservice architecture, which has a lot of services. Say you have about 20 services just to cater to one single application, and you want to build this entire network, and this needs to communicate like without latency. It needs to be fail proof so that none of the functions break, and those kind of things. I would anyway suggest Rust, because that's how secure Rust can give you. So yeah, that is mostly what I would say. But yeah.
Sure. I think we have a lot of questions coming in. Asad, could you please share the link where people can ask questions? The most upvoted questions would be answered by the mentor. Yeah. Lokesh, you can carry on.
Sure. So to begin with Rust, let's first start off with the Hello World program. So before I start, I just want to say, is my screen zoomed enough for people to view, or you want me to zoom in further?
I think
Tejas?
Yeah, you can start.
Okay.
I think we need to zoom in a little further, location. Some of them are asking.
So yeah. So hope this works. So yeah, the first and foremost step is basically hello world, right? So let's try to print the thing. So print ln is the thing, and if you notice here, I have written an exclamatory mark here. So anything that has an exclamation symbol here is in Rust are called macros. Macros are what, to just give a brief about it, those are basically functions that are written that work based on what functionality it needs to provide. So something like that. So, and hello world, right? And Rust is always at the end of the line. In Rust, you need to finish it with a semicolon, right? Once you're done with this, you just need to execute your code, and yeah. So this is your first program on Rust. Okay, there seems to be some
Lokesh,
time.
if you want, you can choose to go to a machine, and
Yeah.
if people don't, the people who don't have Rust installed, they can use it. So you
Yes.
can show it quickly.
Yeah. So say I want to create a new file now. I'll just start it here. Say, so hello world.rs. So Rust files always end with the extension .rs, and so yeah, I just create this file and say them hello world.rs. So the first thing is function main, and I say println. So yeah, with this I'm done with the program. So you just want to see the program, I'll just leave it here. So yeah, now what I do is Rust C. For those of you who have Rust installed, you will know this is the step. So there is an error in the code.
You have one outside of.
So yeah, and now that error should be gone. So what Rust C hello world does is, now if you see, I will have a binary. So if you see, I have two files. One is the hello world.rs, and I have another file called hello world. So this is the binary of the program that I just created. So this is how Rust works. So you first write the program, and Rust compiles this file into a binary that can be executed on your native system. So how do I run this binary? All I have to do is hello world, and you see hello world is printed. Cool. Everybody follow so far?
You can give us a thumbs up.
Yeah, cool. So this should work even on the browser. Yeah, it's working now. So you see here, println, and this one. So one of the things probably people might be asking is, what is this keyword fn? So in Rust, to write functions, we use the fn keyword. So some other functions, like for example, Java has the, you write it as a function. Python has def, and yeah, that's how it is, right? So yeah, and yeah, moving on, let's start off with
okay, so the latency issue is because we are making a call to an API on Rust Playground, so that's why it's lagging a bit. That's why you can choose to go to your core editor if you want on local. So yes.
Yeah, so and I'll also ask somebody, Abhishek asking, is the main function always the starting point of the program? Yes, main is the starting point for your binary. In low-level system languages, what happens is you have the concept of lib.rs, or like library files, as well as your binary. So lib files are basically your modules, and binary files are your executables, the one that your package will look to start the program. So yes, in Rust we have function main, similar to Java and C++, where this is the start of the program.
So what do you mean by binary? So for example, let's say your Zoom application is a binary or your Slack application is a binary. So these are applications that are called binaries. But libraries, on the other hand, are reusable code that can be included by other binaries or by other applications. So that's the main difference. Yeah. Yeah.
Yeah. So moving on, let's just start with some of the basics that Rust, like common programming languages have. So starting with, I want to start with how you define variables, right? So let's keep hello world here and say now I want to declare a variable. So to declare any variable, you use the let keyword. So let x is equal to 5, right? So now I have declared a variable called 5. And so here there's a question that I want people to ask, but I'm going to wait until somebody pops up, or I will answer it myself. So and now I want to print this particular variable, right? So all I need to do is you can print this here, and you say x. So now I have declared a variable called x is equal to 5, and I'm printing it onto my terminal here, right? So yeah, so there's a small question I want people to ask. So exactly. So yeah, I think most of you guys have already started pointing it. Yes, Rust is a statically typed language. So here the question is, I haven't defined type for my x. So all of you who got this particular doubt in your head, like kudos to you guys. It's very nice to see that you guys are on the same train of thought. So yes, Rust, you need to define a type, but what happens in Rust, right, is that it automatically by default any integer value that you do so will have a value of i32 assigned to it. So at this moment the type of my 5 is an i32. So Rust by default, when you write anything, will take it as an i32 value, right? If I were to define something of a greater value and try to print it, like now for example I want to say i8, right? And I want to, so it only has 255 bytes, 0 to like 256 bytes, right? But that's 0 to 225. So if I take 257, now this compiler start throwing me an error saying I doesn't have a value of 257. Can you see? That's it, overflowing. So this is how I'm going to tell you that Rust is statically typed. So even when I just declare a variable with the let keyword, by default Rust will give you the I mean for integers it is assigned to i32. Does this answer the questions?
Lokesh,
Yeah.
so what does I mean? I have no idea.
So yeah, I'm coming to that point. So Rust has different types basically. There are scalar and compound types. I will come to that point. Before I come to that point, let me just finish off variables and constants, right? It's just going to be 5 minutes, right? So this is how you define x and get it. So now I can, if I want to define another variable with x, I can do that. So now I can say x is equal to 6 and then try to print x again. So now I'll get 2 lines, which one specifying 5 and one more specifying 6, right?
Okay, so what happened?
No, there was a semicolon, I mean colon in the center. So yeah. So the concept that I'm trying to explain here is I just want this to be a variable, and I'm just explaining the concept of variables. So what are variables? Variables are types that can be changed throughout its runtime or compile time, right? So here, that is what I'm trying to do. I have assigned x, I've given 5, and then I'm saying I want x to be of I mean 6 right now. But when I do that, you see there is a compiler error that's coming up. That is because you can't assign a value to, so I have mentioned that this is a variable, right? Which means Rust should let me change the value of x. Can anybody who have little bit of knowledge in Rust tell me what's happening here? Why this error is coming? See, I cannot assign
Or let's ask the non-Rust case. Okay,
Ah.
so this should be possible in Python, right? Not just integer. I can change it with, let's say, string or float or any other type like a class. That should be possible, right?
Yes. Yeah, it should be possible. But in Rust, since it's statically typed, you need to make sure even in variables. So by default, what Rust does is a variable is immutable. A variable is immutable when you declare it. So if you want to change the variable's value, you have to declare it specifically with the keyword called mute. So mute stands for mutable. So only when I add mute to my variable that I've declared, now I can reassign a value to that. Right? So 5 and 6. Okay. And similarly, we have constants. So what is constants? So how are constants declared? We just use the const keyword, and constants are followed by, say, right now I want to know the participant count of our thing. Participant count, and say, what is our participant count currently? We have 283 guys. So 283 is the thing. So right now I have defined a constant, but this is not correct, right? So you can see here immediately the compiler is telling me, please provide a type for the constant participant count, right? I need to specifically give my type, say I32. I is an integer. I stands for integer. I32. Now I can define that this is a constant, right? And if I want to print this out, I can, right? We just use the printf statement. But right now here, the most interesting question that I want people to ask, or I myself would ask, is we have something called as constant, but when I declare a variable with let, I can't change it. So what is the difference between a constant and what's the difference between a regular let variable, right? The main difference is that let is a security measure, that when you declare a let without immutable, the mute keyword, by default, it's going to be locked. You cannot change the value. So this is one of the advantages of using Rust. So this way, as a programmer, you can control even variables that are declared. And const variables are available at global scope, while let variables are available only at the function scope, right? So this is about constants and variables. And I just want to cover another part. There's another thing, concepts where, like, so this is immutability. And when I declare let without the mute keyword, and if I add mute, it becomes a mutable variable. Now there's another concept in Rust called shadowing, right? Now what is shadowing? Now, if you see previously, when I tried to execute code with this without the mute keyword, it threw us an error, right? Now I'm going to redeclare x here and let x is equal to 6. And now if you see, this code will compile. I will get an output that says 5 and 6 here, right? Now this is called shadowing. This is the concept of shadowing. So what is the advantages of shadowing? So shadowing lets you use the variable, the same variable name, to give you to use it for a different variable. Now, for example, I have let x is equal to 5 here, but now I want to say let x is of type string, right? I say Substrate Saturday, right? Now I will still be able to do that. So the advantage of shadowing, that I can still use declare different types, and you can still use the same keyword. So so far everybody followed? Cool. Yeah. So now is the time. So I believe people were asking me what is I32, what is all these things. So let's get into the primitive types of Rust. So Rust has basically two basic primitive types. They are the scalar and the compound types, right? Scalar and compound types. So what are scalar types? So what does the word scalar and compound mean? Scalar is a single value, right? And a compound type is a collective of primitives. Followed?
Okay, so can you tell me, like, the difference between primitives, like why do we call them primitives?
So primitives are basically what is defined for you to even start using things. So scalar types are your, I'll just start writing them. Integers, floating point numbers, booleans, and fourth one is chars. So these are the four different scalar types that Rust provides, and you have two compound types. That one is a tuple, right? And the other one is an array. So these are the two compound types that Rust provides. So just by looking at this, what I've written here, you can already say that scalar is for a unit value and compound is for a collective primitive. So integers, floating point numbers, booleans, and chars. Most of you, if you've used Python also, you wouldn't have any problem declaring float. What is a floating point number? Basically decimal numbers to a variable. However, in statically typed languages, you need to specify if it's a float or if it's an integer, right? So a little bit more about these data types. I just want to share the question that everybody had. So I'll just quickly is anybody seeing what's happening to my screen?
Yes, sir.
Okay, it's pretty weird. I don't know how, but yeah. So yeah, control over this.
True.
Okay. Okay,
Bro, your machine has a mind of itself.
Probably. Okay, this is pretty weird. Okay, I don't know what just happened, but let's I'll just open it. I have an interesting comment. Should write real. Everything. So yeah.
Nice comment by Tushar. Rusted.
Oh, nice. And I like even Yash's comment. Floating point costed the float. Yeah, it was nice.
Nice one, bro. Nice.
Yeah.
Correct.
Redux OS is the one that is written on, it's a Linux distro written on Rust. So yeah, coming back to our types, integer types are of basically, these are the different types. You have I and U. U is unsigned. What is unsigned? Unsigned basically does not have a, the plus or the minus gradient to the value that you are defining. Well, I can only be positive numbers. Got it? And so as it says, I8 is 8-bit, and whatever it's 16 is 16-bit, 32-bit, 64-bit, and 128-bit. And in Rust, you will often come across these notations of I size and U size. What are I size and U sizes? They are your system architecture types. For example, if you're running an OS that is of 64-bit, whenever I use I size or U size, it by default the value is of 64-bit. And if I'm using a system of 32-bit, it will by default take a value of 32-bit. Got it? This is about integer.
Can I explain this?
Yeah, go ahead.
I8 and U8 thing. So basically, why 8-bit, 16-bit, 32-bit, 64-bit? You can just name it as integers, right? So what happens is it's all based on your system architecture. So let's say in your system architecture, every memory cell is of 1 byte. So the max it can take is 1 byte, which is 8 bits, right? So when you tell Rust that I want to store an integer, which is of 1 byte, or I8 or U8, it will allocate that one memory cell for that particular value. So what happens when you assign it to 32 bits? So what it will do, it will allocate 4 memory cells. So 8 into 4 is 32, right? So that's how it will store the data that you're storing or you want to store in your memory location. So that's why you have 8-bit, 16-bit, 32-bit, and 64-bit, and so on. And you have U size and I size that's based on your system architecture also, whether it's 32-bit or 64-bit. So it automatically understand what is your system, and it infers from that. So yeah. I hope that's clear. If anybody has any questions.
I think somebody didn't understand. Could you just re-explain it in one line or so, if you can give it to them?
All right. So everything comes down to your system architecture. Okay. So let's say your memory, you have 1 million addresses, and every memory cell in your address has a capacity of 1 byte. Okay, so we are talking in bits and bytes now. So 1 byte equal to 8 bits, 01001 binary. Okay, so what happens is when you're creating a variable, let's say let x colon u8 equal to 2. So what you're telling Rust is that I want 1 memory cell to be allocated for storing that particular value, which is 2. So what based on u8, what Rust will do is that it will store, or it will block that 1 memory cell for your particular value. But what happens when you do U32 or U64? So it all comes down to maths. Okay. So what will happen is Rust will allot 4 memory cells in your memory, within your memory architecture, to store that particular value, no matter what the value is. It can be 8, it can be 16, it can be 3000, whatever it is. So yeah, like you can see, Lokesh has created a variable of type U64. So U means always positive. It can't store -5000 or -1. Okay. So what it will do is that so 64 basically means 64 bits. Okay, it's not bytes. So if you divide 64 by 8, can you tell me how many bytes will Rust allocate to store this particular value? Yes. Awesome. So yeah, so Rust will store 8 memory cells inside your memory location to save this particular value, and that is stored in hex, but we'll not come to that. We can read upon that later. But yeah, all right, awesome.
Yeah. So cool. That is more about your scalar types. So Boolean, how do I define a bool? Now say let y is equal to is of type bool, which is equal to false. And by default, Rust, all your bool values are right. So this is how a bool is. And a floating point number, if I change the same thing here to floating point number, say if it's an F32, I can write this as 3.14, right? And now this is a floating point number. Just to show you that there are no errors for all of these types, you can see that this will compile, and I'll also add characters, right? And say this is a character, and say it's a C.
True.
So yeah, so there are no errors. So these are all warnings because I'm not using these values. So it's just saying if you're not using, you prefix it with the underscore. So whenever you write any function or variable with underscore, it is of private scope, which means an external program should not try to communicate to that or try to reach that piece of code. So these are mostly about your scalar types. Now let's just move on to component types. Tuple, most of you guys might know what a tuple is. Tuple is just basically a data structure of where you can store 2 different things, right? So in Rust, it serves the same functionality. Now say let I want to define what are the details of my so Bootcamp details. So cam details is equal to a tuple is of type tuple. One will be of type string, so and str, and the other one I want to know in this bootcamp how many people participants have joined, right? So I'll just keep it u64, and here I define a tuple which is this is Substrate Saturday, and I have about 283 participants. So this is how you define a tuple. And by whenever you want to access the contents of a tuple, the way you do it is, now say I want to access the first variable, just the name, right? So what I do is Bootcamp.
Bro, I want to interrupt you. So
Yeah, go ahead.
can you add one more value to the tuple? Can you add one more value to the tuple?
Yeah, sure.
Without the annotation. I just want to add one more.
Okay. Oh, wait. Okay, cool. I got it. So, yeah, say I add the value 30. So now you see invalid suffix or.
But why not? You are mentioning U64, right?
Yeah.
So ideally it should infer 283 and 30 as well, correct? Both
Exactly, but the problem here is that we have not defined the third parameter. You have instancialized a variable, like declared the variable here as 30, but I have not annotated the type here, right? So this is how a tuple is. So if even if you want to assign another variable, you need to be sure that you are giving the correct annotation for that type. So and by default, tuples are indexed with 0, and so if the first element in the tuple is 0, 1, 2. And something that you can notice here is tuple is a compound material, which means I can have two different primitive types in any of my compound structures. So which is why I have a type string and these are numbers, right? And now if I try to run this code, you can see that the error was showing below has gone. And now you can see I have printed the first value, that is Substrate Saturday with index 0, right? So this is about a tuple. So yeah, I'll just move on quickly to array as well. So array by default is going to be very simple. It's your regular array. So how do you declare an array? So let's say let some array is equal to of type, say 1, 2, 3, right? So this is an array, and the only difference between an array and a tuple, like one of the differences is that a tuple starts with a normal bracket, while an array starts with a square bracket. And again, you have the same indexing. Arrays also start with index value 0, and some array. And if I want to read a value from an array, so this is how I would do it, right? So you see this code compiled cleanly without any errors. So this is about the two scalar and compound data types in Rust. So any questions so far? I'll quickly 30 seconds to answer any questions. Okay, first side integer. Okay, okay, there are a lot of questions. So yeah, for those guys asking about maps, those are all your data structures that Rust provides, right? That we will be covering it in the later part. And in terms with anybody asking about can I add multiple variables to a tuple? Yes, you can. You can have n number of variables. However, tuples are mostly used to just store a very limited data, like just two things. Like you want the name of a person and an ID, you quickly store it in a tuple, right? That's like, or if you want to store a coordinate, x and y coordinate of a point, right? You already know it's only going to be 2 points, x and y, and tuples are very fast to access. And these compound data types are stored at compile time memory, where everything is assigned, the memory has been assigned to them, right? So yeah, if this is all, we'll quickly start moving to the next topic that I want to cover is how to write functions.
One more thing I want to ask, Lucas.
Sure.
So I see that tuple has multiple data types, but
yeah,
I don't see array having string or some other data type. So what's the reason for that?
so tuple is of a quick user type where you can have multiple data types. Array is most likely to have the same types stored in it. Now, if I want to store different data types in an array, you can always use tuples inside of an array.
Got it. Okay.
Makes sense?
So
And
type inside a type.
yeah, type inside a type. And if you still want to take it down for better coding in advanced types, we have concepts of structs and enums that come into picture, and we have vectors where you can define each single type that are there, right? So I will cover that point later. So there are solutions to define multiple different data types in a vector as well, right?
Sure.
Yeah, sure. So that is this. And so if anybody just wants to know how you store tuples inside a thing, you can just store it like this, right? So this is how your different element inside your array would look like. And arrays are defined at your compile time, and you define the total number of participants, like the length of an array in the beginning itself, right? And that's how it is. So yeah, moving on, let's I just want to give a brief of how basically functions are written in Rust, right? A function is basically, so everybody know about the main function, which is the root of your program, right? And whenever you want to declare a function or write a function, you always start it with your fn keyword. And if I were to write another function right now, right? Another function, it basically you use the fn keyword, you name of the function, you use your regular brackets, and then you have parentheses, right? And inside this, you need to write, do whatever you want, right? Say I want to print something. Print ln, this is another function, right? So yeah, at the end of the line, always remember to leave a semicolon. If you don't leave a semicolon, what happens is you will get an error by the compiler. So yeah, if you see, yeah, the reason I'm not getting an error because though I've written, I'm not using it anywhere. So let's call this function, because my main function is not aware of this function that I've written. So now if you see, this will be throwing an error. Okay, so this is a very tricky spot, but there is an answer to this also. So I will explain the answer to this, but the point is that, say if I write another line, now I should be getting it. So you see, for example, now when I've added another print line, it is telling me please add a semicolon here. But previously, when I didn't write a semicolon, and I've been stressing enough to you guys that you need to add a stressing column, and Rust just gave up on me at the last minute, like you don't know Rust. But it's actually not that I don't know Rust. Rust has a function, like a feature where if you want to return any variable at the end of your function, you don't need to specify the semicolon. By default, Rust will understand that that is a return value. You got it? I was not put on the spot by Rust. It's just a feature of functionality of Rust. So that's how it is. And so basically one thing that I want to point out in Rust is Rust uses snake case convention. So even when I wrote the constants or the variables, you must have seen everywhere there was a space, I am using an underscore, right? So that is this is called a snake case thing. And whenever you're writing variables, the convention is to write all small letters, and when you're using constants, it's all caps, right? So this is more about the functions. And just to explain the next thing in detail, so whenever I want to take a parameter to my function, right now, say I have called another function in my main thing. Now say I want to take a parameter, like I can say x is an i32, and I want y is an i32. And so this is how you define parameters in Rust. So you define the name of your parameter, and then followed by a colon specifying your type of that parameter. So i32 is the type of my first parameter, and y is the type of my second parameter. Sorry, i32 is the second type of my y parameter. And now I can do something with this, right? I can always do something with this. So here, say if I want to print the value of x, I can do so. And right. So now if you see, the compiler will start like throwing an error because I haven't called the function with the parameters that I've specified. Right. So that is pretty simple. You can just, by default, everything in Rust is iterative. So 1 and 2. And now the code should be fine.
But Lokesh, you said types are inferred, right? So why do we need to provide I32 for XML?
So when you are defining a function for the parameters, you have to define the type. So because here you're not passing the value, the function needs to know what type of parameter I'm going to receive. But at a like in the main function level, when I'm giving 2, here I don't necessarily have to give my type, especially for 1 and 2, because if when I say 1, it's by default I32. But if it's not, now say if I make it U32, this 1 is now going to be interpreted as a U32. So this happens because these are primitive types. These are scalar types.
Can I pass in -1?
Yeah, X? You can pass -1 for, okay, for X you can't because it's unsigned, but if I were to do it for Y, you can. So if I make it -2, it should be fine. So you see there's -2 printed here, right?
Cool.
So yeah, that is how this is. Now I just want to know, give you a little bit of depth of what are basically statements and expressions. So in a function, if you see line 6 and 7, these are statements, because I'm not doing anything with my variables other than printing. It's just doing a computation, like there's no real computation on top of the variable. Right. So these are statements, stuff that are just being declared inside a function. Now, what is an expression? Expression is, say, now I am actually, now say I'll keep back this, I'll get this type back to an I, and now if I want to do X star Y, so this is how you multiply two numbers, right? So if I do this now, and now this is an expression. Now let mul is equal to X star Y, right? And now I want to print the same value. So yeah, so this piece of code is an expression. So this is basically the difference between statements and expression. So when I change the value, I can multiply two types of the same parameter, right? So this is more about functions and how you write functions. Most of you should be aware of like how functions are used. So I'm not going to go too much into it because the next sections involves us writing more functions. And yeah, so one other thing I want to cover here was the point when Russ put me on the spot when I said you need a colon, and it was not necessary. So the thing is about those are return types. Now, for example, I want to return this value mul, right? So there are two types of returning values in a function. One, I use the return keyword, right? And the second, so return keyword ends with a colon. And another syntax that you need to make sure is in a function, you should always tell us what are you returning, right? What is the type of the variable that you're returning? So this is the syntax. So it is followed by an arrow, and then you have the type defined for what you're returning. So if I say return and the value here, now here this function will now have a value that is being returned. So now say I want to remove this, and I just say let this is equal to whatever it is, and I just copy this. So now if you see, now I'll get a value that is returned here as -8, and this is being printed from line number 3. So one way of returning, so whenever you want to return types, the first and foremost thing that you need to remember is always define at your function level what is your type that you're going to return. Second, there are two ways of returning a variable after an expression or after your computation. One is using the return keyword. The other way that is that I can just use do mul. without a semicolon in the end. So what does this do is, by default, Rust compiler understands that when there is no semicolon in, that particular variable is being returned as the result of the function. So now you see this would work, right? And if I try to add a colon here, now the compiler will complain. So if you see what's the thing, see, it's expecting an I32, but found an empty a unit type. So what you see in two normal brackets is called a unit type in Rust. So it's getting a unit type, but I have told I need a I32, right? So which is why I'm not returning an I32 here. So that is the error. So if I remove the semicolon, see, Rust compiler is very friendly. It gives you a hard time. It also gives you the solution most of the times. So yeah, you just need to remove this and you're pretty much good with your code.
Okay, so unit type is basically like void. So if you don't mention, if you don't specify it, you're not returning anything. So
unit
that's
is
the
basically
difference.
nothing. It doesn't exist. Yeah.
And why did Lokesh put this inside a print function? Because we need to capture the output, right? To project it to the console. So that's why this function's value is put inside a print function so that we can all see it. Because now since it's returning, we have no way to look at the output, right? So that's the main reason.
Yeah, that's correct. So these are about functions. I know pretty much not a lot of doubts for these, but you might have anything, whatever. If so, let's have it in some time. So now I just want to move on to the next topic is control flow. What are control flow? Basically, these are statements like if, else, whiles, not while. So if, else, if, let's, match statements. These are all control statements that you basically operate on the parameters that you are receiving, right, in code. So how do you write your such things in Rust? Is very simple. The same way that you do it in other languages, your if, else works as the same thing. So now say if I want to take X as a value and I want to do some kind of computation with that. Now say the parameter I'm receiving for this particular function is equal if X is less than 5, right? And if X is less than Y, I want to print print less, and else I want to print more. Right? And let me just delete all these things, and I want to print such a thing, and here I want to return that if X is less than 5, I want it to be false, and if else I wanted to return true, right? So, and one thing I want to make sure that in if else statements you can always use the thing, but it's always safer to use the return keyword, just because you might have nested routes or loops that are going to interfere with your code scope level. So, and here in another function, I just pass this one thing, and let's look at the output.
Okay, so the return statements that you see here, they are basically called early returns. So the other return that you saw was at the end of the function. Right? So when you specify what you want to return prior to the last return statement or the last return value, it's basically called an early return. And also notice the intricacies of this control flow. In some languages, you put parentheses around the conditional, which is X is less than 5, correct? So here you don't have to put a parentheses inside or outside your conditional values. So yes.
Yeah, that's correct. And so I just want to quickly show you a demo of nested if and else. So this is a nested if and else. So I'll just change. So yeah, so this is a nested if and else. So this is how the syntax looks. So the main takeaway from here is just how you look at the syntax. So it's if so basically you're checking for divisibility. The number is divisible by 4, 3, 4, 3, and 2, and you can just represent your else ifs here, and they should also be fine, right? Okay, expected bool, right? So I'm not really doing something here, so for the sake of it, I'm just removing it here, but I hope you guys get the point, right? I don't necessarily need to be returning anything, but the main takeaway is how these are being written. Yeah, so you see the number is currently divisible by 4. So the other thing I want to quickly is like for those of you who know that you can quickly write basically the if and else condition in your let statements, right? Now, for example, if I have let rest is equal to another function, and I have a very small boolean check to do, right? So now say first I introduce a variable let x is equal to true, and now if I want to check it, right? So it is very simple. So let result is let if x. So if x is true, right, then print say something like just assign a variable. Say if x is true, like say it is correct, else say else I just want to return, say in web host servers you want to return a 404 error which is not found, and now I just want to print it. So yeah, this is basically a single line error, but okay, so here if you see there's a type mismatch, right? So the main reason is because here I'm trying to say if x is true, I'm returning a string type, but else I'm returning a type of integer, right? This cannot work out in Rust. But the real question here would be, so you're saying I cannot return two different things when I'm coding my servers. You definitely can. There are ways to do that, but in your regular if else, I mean like regular conditions, you can't do it. How do we come across these issues? These are using structs and enums, which I'll be covering in some more time. So this is one error that I wanted to show you. So here I just return something, so this should be fine. So basically you need to the return type needs to be of the same initial variable type. That is the main takeaway from here, right? So we're done with control
why
flow.
this approach? So basically this helps in, yeah, so I'm just explaining like why is it only expecting like one type, why not both the types, correct? So this basically leads to a lot of undefined behaviors in code. So for example, let's say in other loosely typed languages, when you're returning, when you're not expected a certain type and you're not expecting a certain type and you get something else, your code is bound to crash. And when you the main problem is when it scales, that's when you are really confused about the entire code. So that's why, to begin with, it's really, it has all these rules that we have to amend. So yeah.
Yes. So moving on, I'll just go to the topic of loops. In Rust, like all other programming languages, we have loops. There are little bit changes. So we have, basically there are three types of loops that we can write in Rust. One is, it's called using loop. Loop is the name of the keyword, while the next one is the while loop. This is familiar. The next one is called a for in loop, right? So I'll quickly give you like very small examples of all these things. So basically, if I want to use the loop keyword, I just say loop and say I want to print right? So this loop is a keyword that always keeps looping. So this is a forever loop. It's basically while true, you just keep executing your command, and this will keep printing it, right? So this will eventually crash the browser at the moment, but yeah. So I hope people understood what what, so if I want to break out of a loop, you can like come out of a loop. Basically you can use the break keyword. Currently this is not executing, probably this is giving a command to run this print statement forever, right?
This will never execute.
Yeah. So I should, yeah, so it's not able to handle this because it's on a continuous loop, right? And if I use the break keyword, so this is the keyword that you use to break out of a loop, right? If a certain condition is achieved, you want to break out of the loop. So if you see here, line number 7 was executed and the break keyword breaks the loop, right? This is the first type of loop that we have in Rust. And whenever you want to do something with loops, right, you always use the break keyword. And now an interesting thing that I want to basically show you is, now say I have a counter, so let counter, I initialize it with 0, right? And then now inside a loop I'm going to increment my counter, right? How do you increment variables in Rust? It's very simple. So this syntax most of you guys must be aware of. So here I'm increasing my counter. Now I want to break my counter if counter say counter value is equal to 10. So this is a comparison state, right? If my counter value is equal to 10, I want to break, right? So what will happen? So now the counter is going to run, and
The spelling.
yeah. So this will print never ending for 10 times and it's going to break out of the loop. So there is another concept in the break statement. You can even return values on a break statement. You get that. So now say I want to return some operational, some expression at the end of my break statement, right? I can do that. So this is one other feature of Rust that Rust gives us. So what we can do is say let rest is equal to a loop that breaks at 10, and once the code, once it has reached the break line of code, I want to do an expression or I want to compute something. Say I want to return counter into 2, and this is basically how I break and return a value from my break statement, right? So now if you see, I should get the value here. I'm missing something. So it is because at the end of let, so when I have given let a variable rest, because I'm returning a variable, so I am returning a value, I'm assigning to this variable rest, so it needs to have a semicolon at the end. And now if I do it, it should be fine. So if you see, it printed never ending, and if you want to see the print thing, so yeah, now you'll get the total value. So never ending 20 times. So this is the way you return a value at using the break keyword, right? This is most of how what loops are about. And moving on, the
Lokesh,
next
one more thing. I see that you have used break as the return keyword. So can I use a return keyword?
Definitely you can, but to break in a loop, you need to use break. But let's use the return.
Let's try it.
Yeah, so it says expected unit but found integer. So here the thing is that whenever you're using return, it is of function scope, so which means you need to define what is your return type. And I'm not doing that here because it's just a regular loop. I'm not writing a new function. But break lets you break your current loop and return the value. So thank you so much for asking that question, Tej. I think this was really helpful. So this is more to do with the normal loop. And next we'll just move on to a simple say a while code. While is very simple. So it's going to be, now say okay, I'll not delete the code, I'll just comment it. say while the counter is not equal to 10, right? While it is not equal to 10, or while I just leave it as a 0, I don't want the
less than 10 maybe.
web browser to crash. Yeah, so I just wanted to keep it very simple, so in sake of simplicity, and say print something, right? And now what I'll do, I will counter -1, right? Every time the while loop is happening, I want to change the value of my counter, right? And now say I start off with 10. So yeah, so you see something is being printed continuously, and when, so initially I have initialized my counter to value of 10, and while the counter has been basically reducing the value of a counter by 1, it finally hits 0 and it's out. This is the while loop, right? This is how you use while loop.
Okay,
And
so
to come out of while loop, you give a condition.
so the things that you see minus equal to and plus equal to, they are assignment operators, but what is happening? So the full syntax of it would be counter is equal to counter plus 1. Okay, so this is just a short way of writing it, and cooler way of writing it. So yeah, all
Sure. Yeah, that's about while. The third type of loop is something unique actually in Rust. Reason being, you can use this in multiple languages. There, like for example, for each statements that you use in other languages. So this is called a for in loop. So what does a for in loop mean? So it is basically for. Now let me assign a value here. And let say array is equal to 1 2 5, right? Now I have 4 values in my array. Now I want to iterate over this array, right? For element in this array, in array dot iter, I want to print the value, print ln. So this is a for in loop. So here something that you need to understand here is the iter keyword. I know it is new. I will come to this. So if you see, I am being able to print each and every single value of my array. Iter is just basically an iterator. So those who have worked on like say Java or C++, you have a class called iterator, right? Which you need to implement. Correct. So that is the functionality of iterator. Iterator gives you an element. It's a trait, or like it's basically a characteristic of a data structure which let you get every single value in that data structure. So that is an iter. If I want to do this without the iter, you can still do this, right? In Rust it will work, but what happens is, because in the background array is by default implements the iter trait, which is why this will work at the moment. And if can I change an element in my array? No. Can anybody tell me why I can't change the value in my array? Yeah. So yes, it's immutable. Correct. So that is mostly of what it is. And now I'll just show you a small trick of something that is very interesting in Rust. Now you have this syntax of dot notation in Rust, right? Now say if I want to do 1 to 4, so this will print values from, can anybody tell me what it'll print? I just want to know how many of you have used this syntax or know this concept.
1 2 3 4.
Okay. Okay, so those of you who said the values 1 2 3 4, you're all wrong. So yeah, so in a range,
I have
dot
123
notation.
also, Lokesh. I have 123, 23, 23, 4, 5, 6.
Okay, guys, I guess you guys got confused by this line. So this is called a range notation. Whenever you want to depict a range from a certain range, you specify the starting of the range and the end of the range. And this end of the range is not included, which means here 4 won't be included. It'll stop at 1, 2, 3, right? And one interesting thing is you just do dot reverse, and now you see it'll start printing 3 to 1, and so you see element 3 to 1. So dot reb on a range will reverse all the this one. And so the main takeaway about range syntaxes are whenever you are specifying the last the end of the range, it is not included, right? It's excluding that value. So if I want a range from 1 to 5, I need to specify 6 as my end of the range, right? So now I'll get 5, 4, 3, 2, 1, right? So this is how it is. So these are mostly about your loops and control flow statements. And I think I have pretty much covered most of your basics and things for all of you to relate to Rust at this moment.
I want to interrupt. Lokesh.
Yeah, go ahead.
So I want that 6 also to be printed. Is that okay?
So yeah, you can print 6 as well. I believe you just need to do this. Or there is a way.
Oh yeah, yeah.
print
It
6.
was an equal to.
Yeah, I'm sorry. Yeah, equal to. So if you want the last variable, it's equal to.
Not recommended, but you can do it.
But yeah, you can still use all these syntax. It's an equal to, and you see 6 is also now included in this. So with this, I've completed loops, and quickly I just want to show you about the comments. So you see there are single line comments. These are single line comments followed by 2 forward slashes, and block comments are followed by this. This is the notation for your block comments. And these are mostly your basics of what you need to know. And so far, any questions? It's been a long session. So we are open to questions so far from anything that we have completed. So yeah. Let's just... Okay, there are a lot of questions coming in. So yeah, I think, Harsha, can we open the mic? So if they want to raise their hands and ask, we can do that.
Yeah, they can raise their hands. We can unmute them in case if they have anything. Otherwise, Tejas, you can take questions in the chat. Yeah, Sahil, you can ask a question.
Yes, can you tell how can we define the step? For suppose in loop, I want the step as 2. In for loop. How can we define the step? Like I want the loop to run from 1, then 3, then 5, then 7, like that. Only alternate numbers. Like,
Correct.
yeah.
So that you will have to use a loop. You will need to use a loop. In a for and loop, what happens is it takes every single value in that loop. It's basically a for each. You understand? So if you want a condition for your loop to run on, you will write, you will use a loop, and you write the condition of if I is an odd value, right? And then you do that thing. So one of that solution is that. So that's how you do it.
So there is something called a dot step by. I think you're mentioning the step. So in Python, you can mention steps. So it skips 1 or 2 numbers based on your steps. There is a dot step by function, and in that dot step by function, you can mention the number by how many numbers you want to skip from the number that has been printed to the next number. So you can do that.
Got it.
All right. I think Fahad has a question. He's been raising his hand for quite some time. Yeah, Fahad.
basically ask, maybe I missed it. You mentioned about, you've put a keyword element. Is that a keyword, or did you declare it somewhere above the for loop?
No, it's not a keyword, it's just a name. So it can be anything here. It can just be L. It can be anything.
All right. Okay. Thank you.
Yeah.
So you can imagine it as representing all the elements that are present in that loop. So when the first iteration is struck, EL is representing 1, and after the loop ends, EL is representing 2, and so on. So that's how it is mapped.
Okay. Thank you.
Anyone else have the questions? If not, Tejas, you can take questions from a couple of questions from chat. Right on this.
Right.
Yeah.
Yeah, a tuple can also be looped. So any iterable can be looped.
All right. We have one more question here from Ignacio. I'm sorry, I got your name wrong. Yeah.
Yes.
Sure, please.
Hi, hello, here Ignacio. I was wondering if you could, like now we are getting very in detail into Rust, but if you go back, maybe not now or later, to the for a more global perspective to understand why we are learning Rust, to try to understand the ecosystem between Polkadot and why we are learning Rust. Maybe you will discuss that later, but I want you to put it on the table. Thanks.
Got it. Sure, I can take a small timeout for 5 minutes to just explain why we are doing all this. Is my screen still shared or?
Yeah, it's shared.
Okay. So Polkadot is a blockchain, right? So we are trying to, so what's the difference between smart contracts and Substrate framework is that on smart contract, we're just building a single module which speaks to the contract that is deployed on the host chain. For example, on Ethereum, you're writing a contract which will be deployed to the host mainnet or testnet or whichever network. Right, that's how it is. But when you come to Polkadot also has the concept of smart contracts, where you will be using something called as Inc smart contracts, and the other thing that Polkadot offers is is the framework called Substrate. What Substrate lets you do is let you build a palette. Palettes are basically libraries, and you build libraries, and you basically take the Polkadot chain, the Polkadot's configuration, and you add your own libraries to customize and build your own blockchain. So this is your Substrate framework. This is what Substrate does, right? And if you see Substrate, basically this is the node template or to get started off developing on Substrate. And the first and foremost thing if you see is like the entire code for Substrate is written. So this is the code. So if you see it is heavily written on Rust. Polkadot, the entire blockchain is written on Rust. Not just Polkadot, even if you see Solana, Near, all the even Definity chain are all written on Rust. I'm talking about the main blockchain. So Substrate is giving us the power to write our own custom blockchains. Right, so it's completely written on Rust. And to give you a small brief look at how a single file, so I was talking about lib.rs and main.rs, we'll get to this point, but this is how a project in Rust would look like. When you build it on Cargo, it'll have a source folder, it has a terminal file. Terminal file is basically you declare all your dependencies, your dev dependencies, and your features and all that thing. It's basically package.json for JavaScript or TypeScript guys, requirements.txt for Python guys, and those kind of things, right? And if you look at the code here, it implies, I mean, it uses a lot of intermediate level Rust. So far, if the code that we did on Rust is just basics of Rust, how to write control flow statements, how to even write a function, what are the different types available. But looking at this piece of code, if you see just to write a small config, you can already see there's a, I mean, these 3 lines were pretty much crazy complex for me enough when I started out Substrate framework. Right, you can see the syntax you have. These are called attribute macros. I don't want to overload all of the participants here by showing you complex code, but I'm just telling you what these are, right? So we will get to this point, and it's not very hard. Trust me, it's not hard to get to the point of writing code at this level, right? There is a learning curve, but it's not hard. It's easily doable, right? So these are called as attribute macros. I have already shown you one type of macros, which is println. Println is a normal macro. If you see, this is with an exclamation mark. This is a regular macro, and these are called as attribute macros. For those who have worked with Java or even Dart, you might know all these things. And if you see here, this implements a config. So this is a trait. You're defining a trait. A trait is an interface. In OOPS concept, you have the concept of interface, right? What is an interface? An interface is basically just a character that has a list of functions, right? That you're not writing the core logic of the function, but you're just saying, if I need to have an animal character, that animal needs to make a sound, it needs to have a name. These are all interfaces, right? Which animal has what sound and what name, it comes to your class. You would define a class for that animal, and then you will define the parameters, right? That's how it is. And so that's the same concept of interface here in Rust, which is a trait. But the complex thing here that you need to look at is, for a config, I'm implementing another type. So this is my type. This is a frame system config that comes from a different package. This package name is called frame system. Similarly, I can have multiple traits implemented for custom single thing. And these are, so if you do not understand the ownership and borrow model or the traits model of Rust, this figuring out this piece of code will start getting a bit tricky. So even in line number 26, you see, I'm defining a type. I'm defining a type event, and I am saying that event is, so this sentence is very confusing, right? It says from event self plus is type self frame system config event. It's very confusing, right? So I mean, you can't understand. But if you ask me what's happening, it implements this event type, implements the from trait, and this from trait in turn takes a parameter of two types. One is a self event, that so event type that is being given as a trait, and second is a self points to this current mod, right? Self points to this current mod palette, and plus is type, it implements is type feature and is type of config. That means this event implements the event trait, and also for this current module, it should also have implemented that it should be well within the regulations of this frame system config event. So it should basically have these standards and also should have this type. So that is what this piece of line means, right? So this is how the code on Substrate looks like. So we definitely, all of you who are part of this will be able to start coding at this level in 3 months for sure. But this is just talking about the coding intrinsics. But now if you look at the ecosystem, Substrate is a framework that is like heavily built on Rust, and all the systems, like the Rust ecosystem has this entire Polkadot blockchain built on it. You have servers written on Actix or Rocket and all these things. So then again, like I mentioned, why Rust? Rust is basically that it provides security. So like I said, even whenever I declared my variables, for example, counter, I have not deallocated it from memory, right? Though I told you Rust has memory handling that you have to do, I have not deallocated the memory. But when it comes to C++, if I had declared this counter, I need to allocate. So here I would have allocated some memory to it. At the end of the function, I need to deallocate it. In Rust, because of the ownership model, which I want to explain in detail, at the end of line 27, by default, the variables declared inside the function scope will be dereference. So it implements the drop trait. So in Rust, you have something called as a drop trait, where this variable counter that I have defined in line number 6 has been dropped at line number 27. So this is how memory handling happens in Rust, right? So this ensures that a programmer writing the code is not given an opportunity to commit a memory issue like segfault errors that C++ has, right? You're not giving him the freedom to commit errors. The compiler will start compiling for every single error that you make, even before your program tries to, is on the process of compilation. So that is one major thing. And second, because there is no garbage collector, it's quite fast. So these are all the advantages and perks of Rust, right? And it's a very robust, strong ecosystem, and it's mostly used for very fast and security things. So why I'm in stressing security so much is because most of you guys, if you know, your Visa payment cards or your financial systems are mostly written on Java code, right? Java is secure. One of the main reasons is because it is type safe again. So Rust, so even the fintech domains have started experimenting Rust to be used as their code basis. So this is the thing. So when it boils down to what project you're doing, it becomes a choice of favor on what ecosystem you want to use. And it also depends on the scope of your project, how heavy or how big your project is. Does that answer your question briefly, at least? It, I mean, what else? I lost the name. Yeah.
Okay, so the code that you saw for Substrate, I know it looks a bit challenging, but once you get down with the basics and you know it really well, it'll be a piece of cake. It'll be like Python for you after 3 months. So don't worry about that. And also, I saw some questions related to loops. So it basically comes down to how you want to use it, right? For example, there is a loop called loop. The name itself is loop. So it makes sense to use loop when while is always true, like Lokesh said. While true doesn't make any sense. It'll just keep on iterating until and unless you break it, right? So that's why in those circumstances you can, when you have a continuous loop, you can use the loop, and if you have a conditional for a while loop, you can use a while loop. And mostly for loops are used for on or on iterables. Iterables are your tuples, any kind of array, like vectors and stuff, or strings. So whenever you want to print everything inside an array or access every element inside an array, without the break keyword, you use the for loop. So it all comes down to how you want to, or what part of the code you want to use. So yeah.
True. So guys, I have a small question. I know it is the end of the session, like we're already reaching the time, but however, we still have, I mean, there is still some of the topics that needs to be covered. First and foremost, I want to ask you, was the pace for the session good enough, or is it okay for me to speed it up? Or if you want me to slow down also, yeah. Okay, so yeah, I think most of you are saying I can speed it up. Yeah, and cool. If everybody's okay to sit for another half an hour with us, if that is okay, I will cover the ownership and borrow model of Rust, which requires detailed understanding, and it's going to take some time because understanding that concept is the main this one. If not, we can do a small 15-minute guessing game in Rust. It's very simple, like a basic thing. Basically, it's a project that you have learned, whatever you've learned so far. We just build a very small project in say about 10 to 15 minutes, and we can end the session. So please let me know what you guys want to do. And Harsha, would it be okay to take a poll quickly for it? Ownership.
Yeah, once again, I think most of the votes is not, I mean, we have 50-50 thing, so you can take a call in case if you want to continue, or like how we can push. I think we can push it to a later session. So what we can do is, if you have an assignment, you can share it of whatever you have done it. So I think that will be a little challenging. In case if they have any questions, they can ask us on Discord. Asit, please share to the Discord channel. In case if you guys have not joined in, please join the Discord. So we can take we can have a Q&A session in the midweek, right? In case if it's required.
Sure. Yeah, we can do that. So with respect to the assignments, what I want people to do is, so you can search for Rust by example, Rust by practice. So Rust by practice, you will immediately come on this link called practice.rs. So I'll just paste this code in the chat, I mean the link in the chat. And what happens here is, so the see I would give you guys questions personalized on the assignments, but however for basics I want all of you to finish this exercise thing. So at the moment, so how much we have completed, right? So we have completed up to flow control, right? I have thought these things. So if you guys can complete even the next pattern match is very simple. If you can do it, so that will be great. And those of you who are going to actually attempt the assignment, like I said, I want you to so you can either clone this repository, like there are guidelines on how you can do that, or you can always take the Sunface Rust by practice. You can clone this. So what happens is you will first get only the questions, you will not get the solutions. There are solutions also provided. So it's all, see, I don't want to be like not giving the solutions. All the solutions are provided. It all comes down to integrity and how much you want to do it by yourself and what you basically understand by doing yourself. You can also look at the question solution to maybe understand it better, right? So it's all up to you guys what you want to do. You have to clone this. There are good examples on how you do all this, and basically start solving each and every single exercise that is being given in the book, right? And every time you solve the exercise or a single question, please commit it to your personal GitHub account, so that way what happens when you are submitting the assignments, we know that you have attempted these many questions, right? So that's how it is. Just to give you a small look at how these questions are. If you see, if I click on numbers, it says it's a very simple thing, right? Tips: if you don't have, I mean, remove something to make it work, right? Can quickly somebody see what? Just look at this piece of code and tell me what you can do.
Can you zoom in a bit? Yes.
Yeah, I have zoomed in. So if I'll just show you the error statement as well. So if you see, there's an unexpected due to this type, let y, and expected u32 but found i32, right? So yeah, with this error it should be pretty much easy.
Remove y equal to x. Will that work? Remove u32. So this is basically most on, yeah. Can you try that?
Okay.
Right.
Yeah. So this is as simple as the exercises. It's very simple, but the point here is you need to understand. So the bright side of using these things, I mean, one thing I like about Rust is that documentation is very good. They have an ecosystem. It's open source. It's all done by people who proactively have interest toward Rust and building it. It's not funded by a company or a company promoting it, right? So you have a very good Rust book that is there in like for you to read, and you also have these Rust by practice, by where you try to understand what is the error. First you get the error and then you try to solve what the error is, right? So this is how you do it. So for people doing it for today's session, I think if you can complete up to 8, that is pretty much good, right? Yeah. And ownership and borrowing, not everybody, I have not explained the entire concept, but if people do want to attempt it and learn the concept of ownership and borrowing, you're free to do so, and it's a bonus for sure. So that is all from my end.
So someone is asking, how do we submit the assignment? So guys, please join our Discord channel in case if you have any questions. Tejas and Lokesh will be available on the Discord. Not every time, whenever they have a chance to respond to your questions, they will definitely do it. Asad, can you share the Discord link again? So we have Discord link. Please do join our Discord link in case if you don't have. In case if you're stuck somewhere, please do ask the questions on Discord. We'll be happy to answer. Along with Tejas and Lokesh, we'll have many other people who will be guiding you guys along the way. So yeah, I think we have come to the end. So in case we'll just wait for another 5 minutes here in case if you guys have any questions, or if you want to just unmute yourself and ask anything to the mentors or like about Polkadot, we are happy to answer that. You guys can unmute yourself and then do it. Meanwhile, if you have anything to share about the mentors or anything needs to be mentioned, or if you want to network, share your LinkedIn or Twitter handles in the chat so we can connect.
Hi, everybody. Location pages. Is there any like a sample apps for like say electronic health records using Polkadot?
Sorry, could you please repeat that? I couldn't catch the question.
Is there any sample apps like there's for electronic health records using blockchain, right? Using Polkadot as the blockchain technology.
Yeah, I think Tejas or Loki.
So, hi, yeah, go ahead, go ahead.
So sample apps related to electronic technology. That's
No. Electronic health records.
Health records. Okay. So health records are using Polkadot, right? That's what you think, right?
Yeah. Or are there any like I don't know if I can ask if Polkadot is open source or how is it like?
Polkadot is definitely open source.
Okay.
Yeah.
Then is there there must be some GitHub link for Polkadot, I guess.
Everything is available. So I will share you a link of there is a dedicated site called polkaproject.com where everybody who are either on test network or the main network, like the main code, have built projects on Polkadot. So you can definitely have a look at it. So to answer your question exactly, are there health records? I do not know. It's called polkaproject.com. You can always go through it. There are all the projects that are built on Polkadot, NFT marketplaces, gaming, and health. But one thing I would like to add for health record is recently I have seen the community trying to solve the problem of storing records of patients on a decentralized blockchain so that the patient is easily verifiable through multiple different chains of hospitals. This has been a project. I don't know if anybody has done it, but yes, this is definitely an idea that Web3 is trying to do.
Yeah, okay.
I've shared the link for Polkadot's GitHub, so you can go through that. Fahad, is it?
Yeah, Fahad, next you can go.
Okay.
Yeah, thank you so much. You had mentioned about, correct me if I'm wrong, you had mentioned about two pathways. One was that you learn, you build on the Polkadot ecosystem using Substrate, and then you build a library, and then you add it in the Polkadot ecosystem. You also then mentioned that you can develop smart contracts, which you said is something like, which is Ink, or using Rust. So is it two pathways for developers? So like if I'm learning Rust, I could use Substrate as a framework and build libraries for Polkadot, or if I'm learning Rust, I could write smart contracts, just like how I write smart contracts in Ethereum, for example. You can do both.
You can do both. Right. So it boils down to the use case. You want to write smart contracts or you want to build a blockchain. So in Substrate, we call it as palettes. You build palettes.
Right.
And palettes are actually libraries in the real meaning of it. But you can do both. And Rust opens you various opportunities, wherever you want to use it, like Solana smart contracts, Nia smart contracts, Definity code. So there are two roles to a blockchain developer. One, you are a blockchain app developer, which means you're writing smart contracts, you're handling the app and stuff. The second is core blockchain development. And most of the core blockchain development profiles that you see out there are mostly comprised of Rust, because the blockchains itself are written on Rust.
Got it. Okay.
Like for example, Definity chain is one example. The entire Definity code, the chain, is written on Rust. However, they do have another programming language called Makoto, which they favor to write. So Makoto is a much simpler language so that people don't have to get into Rust to write simple things.
Okay. All right. And are we going to learn Substrate also in this course, or we just focus 100% on Rust?
No. This is a main blockchain course. So we will teach you enough Rust for you to start off with Substrate.
Got it. Okay. Thanks for
because
that.
Rust is too wide. there are multiple domains Rust is used for, and we can teach you how to use Rust. So where you want to use it is all up to you.
Okay, all right, thanks.
Yeah, Fahad, we have shared website link where it has all the curriculum there, so that would give a clarity what will be covered for the sessions.
Thank you.
All right. So anyone has any other questions?
So yeah, the homework is from point 1 to 8, if you can cover it. So it's not from 4. I just showed you 4 for an example on how simple the exercise is, but what you need to be doing in an exercise. You need to understand the error. That is the main thing. So the answers will be from, I mean, the assignment is from 1 to 8. So yeah.
All
So
right.
Kusama is also a chain like Lokesh, you have disappeared.
Yeah, Lokesh, we can't.
I have a power cut. So yeah.
So how do we submit the assignment? So submit in a Discord channel. So one of the mentor will answer the question in case if you have. Otherwise, we'll review it and share the feedback over Discord itself. So we have a question from Satarupa. Sorry if I got your name wrong. If you can unmute yourself and ask the questions.
So I had a question regarding the assignment. So the repo which you have asked us to clone, so do we clone that repo in our own GitHub account? And then
yeah, you can just poke it and
yeah, so can we just create issues for the incorrect lines of code, and then we can solve those issues as commits? And is that the way we are supposed to do this assignment?
No, you don't need to submit issues. The thing is, you can go just head on to practice.rs. There's a proper guideline on how you can do it. All I want you to do is you have a question, right? You can just write a solutions folder and put all your solutions in that folder so that I know what you've done. And if people can comment on basically what is the error that they faced and what did they understand about the error, that would give me a little bit of more insight on, okay, yes, you understood what I wanted you to understand.
Thank you.
Does
and
it
thank you for this
answer?
wonderful session, Tejas and Lokesh.
Thank you.
Sure.
Thank you, Satrupa.
So with regards to Rust, we will be covering. So ideally for today's session, I wanted to complete off ownership and borrow model, which is the most important thing, which will require about half an hour of dedicated focus, and the most important thing about Rust. And apart from that, I will run you through the data structures of Rust and structs, how you start writing. Like structs and enums are basically your building blocks of Rust, right? So I will be completing chapters 4, 5, 6, 7. You guys can do it on your own. 8, I'll give you a small intro to that. It's basically about all the vectors and hash maps that you can use. With today's session, it is pretty much good enough for you to do it on your own as well. Because it's very simple on how you create a vector or how do you start up a hash map. Basically, a hash map is similar to a key value pair. So in Java, you have a map. Exactly. In Python, you have dictionary. Even in JavaScript, you have map, right? And vector is what we call it in Rust, and it's called vector even in C++, right? So vector is a dynamic data structure, which means it keeps increasing or reducing, right? So that is what it is. And error handling, I will teach you a little bit of like basic what happens when you want to throw an error, or how do you handle an error. So with this, and this was mostly what I had planned for today's session, but I believe with the interest of time we got a bit slow, but yeah, we can cover this up. Moving on, the next session would highly comprise of things from generic data types to traits and lifetimes, a bit advanced. So the next session is going to be mostly comprising of a little bit of intermediate concepts of using generics, traits, lifetimes, and that would mostly be the session. So I'll teach you about iterator types, how do you what is generic. So most of you may not have heard generic type handling. Those of you who have handled Java or so might know generic type handling. We have the same concept of generic even in Rust. So covering those types, and that is pretty much for our Rust sessions. And apart from these, I will also cover chapters from these closures and advanced traits. And here, these things I will be covering. So once we are done with this, we are pretty much good to go start off with Substrate, right? Substrate will be our third session, like I shared previously. So we'll directly come on to our how do you start a Substrate project and start coding on Substrate. So that is what the curriculum would look like. And about what we'll be covering on Substrate, I think it's there's a detailed info of what everything is here. You can always come to this site and have a look at what's going to happen in every session. But yeah, and one thing, like I said, if people are ready to follow chapters, so to complete chapters 7, you can do 7 on your own, 8 on your own. 7 and 8 are pretty simple. 6 is also enum and stuff. I will also explain it to you, but reading it on your own is also pretty much good. Yeah, so these are the only things I want to mention. So
we should do that, bro, in the next session, definitely. But
we will definitely take cover 5 and 6 for sure, but it's you guys are open to learn it on your own as well. 7 and 8 are simple concepts, so you can pick it up. Sure. Any questions?
So much, Lokesh, Tejas. I think, guys, we are done. Before we exit, I would like to thank Kavya, Asad. So we had about 3,000 plus applications, right? So it was very difficult for them to shortlist, and you guys are here today. Can we have a round of applause for them?
Sure.
Super.
Okay, thank you so much. So we'll meet you guys on Friday. Thank you so much. We'll keep you guys posted.
Yes.